Hello, Keith Rucker here at VintageMachinery.org. Well guys, today I'm going to be working on doing some machining, some over on the horizontal mill as well as on the surface grinder, getting a couple straight edges ready to be scraped. Now, these are what we call camelback straight edges, and I've got a couple. I've got these two here that I use when I'm scraping in machines. I use them as a reference surface. Now, if you're not familiar with a straight edge, what you basically have is you have the bottom of this is a perfectly flat surface. We scrape it in to be perfectly flat. We use a surface plate as our ultimate reference, but then we scrape this in as well as this front dovetail in flat. What that allows us to do is to have a reference when we're scraping on the machine. Now, ultimately, your surface plate is your ultimate reference in the shop. That's what you're really kind of judging everything against. But sometimes you can't take the surface plate to the machine or take the machine to the surface plate. Particularly if it's a large machine or you're working in a dovetail way or something like that. You need something smaller to get in there that you can manage. And that's where these straight edges come in. So I've got two here that I use. This is a 36-inch, this is an 18-inch. And they're nice, but sometimes for some jobs, they're a little bit on the large size. So I really wanted to get a smaller straight edge that I could use for doing smaller pieces. And let me kind of show you an example. What I've got here, this is the compound off of my Monarch lathe that I'm working on right now. And I really haven't done a whole lot to this yet as far as scraping it in. During one of the scraping classes, we did do a little bit on the bottom, but that's really about it. And it's not even complete. But this is a classic case of where sometimes you can't take the part to the surface plate. Now, I can easily check the bottom here on the surface plate. I can just take it over there and lay it on there. But when I start working on these dovetails and I need to get these scraped in, what I have to do is come in with a straight edge and drop it down in here. Oh, that barely fits, number one. And then get it in here and you lean it up and you use that for your reference. On something small like this straight edge, while it's usable, it's a little bit large and bulky. So what I want is something more along this size that I can get down in here that just makes it a little bit easier to use. Now, a lot of people will just make this out of Durabar. They'll just get a piece of continuous cast iron, and they'll cut a dovetail on it, scrape it in, and you're good to go. And there's absolutely nothing wrong with that. In fact, that's what I was actually getting ready to do. I was going to get me a couple pieces of Durabar and make a couple of smaller straight edges. And I said, you know, I really like the looks of the camelback design. And you know, it really does kind of make it easier to handle this one here when you can grab it up here rather than having to put some stobs on the end on a piece of Durabar. The problem is that I couldn't find anybody that made these smaller straight edges like this. No problem, I'll make my own. So again, using some of my collaboration with some fellows that I've worked with before, I went to my buddy Charles Marlin, who is a guru at drawing things up in SolidWorks and 3D CAD design, told him what I wanted, gave him some dimensions, and voila, he draws this thing up just perfect for me. We then 3D printed these pieces here to use as patterns. We scaled them up for shrinkage in the foundry. These are actually plastic 3D printed split patterns that I sent to a foundry, sent these to Cattail Foundry, and they cast these straight edges for me in gray iron, which is what you should use for straight edges, is gray iron instead of ductile iron. At least that's what I've been told. So now I've got these. So now what the game plan for today is that we're going to go ahead and get these machined, and then I'll probably take them to the surface grinder and grind them in, and then we can go and scrape them in and get them set up so that I can have a couple of more reference pieces here to use in the shop. That's the game plan. This is a 9-inch length. This is a 6-inch length. The 9-inch one here I think is going to be really handy. The 6-inch one, if I'm working on something really small, and I think I'm going to actually, after looking at this, is I'm going to nibble this thing down so it's not quite as wide in the bottom and on the front here. It's going to be much smaller base on the bottom. I got a lot of material down here, but I want to make this a good bit smaller because this would be used on really a very small part, and I'm worried that the width may be too wide on a little bitty teeny tiny cross slide or something like that. But we're going to machine both of these down and get them ready for scraping in. So I'm over at the horizontal mill now and game plan here is we want to get the bottom of these machined first. We will then probably machine the back side of this just square. And I think as far as the dovetail goes and the top goes, we're probably just going to do that straight over on the surface grinder. I could do this on the milling machine. I've done them in the past on the milling machine. Bottom line is it's just really hard to clamp these things down at that 45-degree angle. I can do it over on the surface grinder in the magnetic chuck with some magnetic V-blocks very easily. And it takes a little bit more grinding, but hey, it's actually easier than trying to machine it first on the mill. So that's the game plan. Now, when I had these casts, I had a couple of extras done, so I'm going to go ahead and machine a couple of these at a time. I'm going to set up two and just do them all at the same time rather than having to go back and do two different setups. So we're going to just start by clamping these things down to the table like such, where the back side is sticking off, and we will come in here with this face mill and mill that flat. So let me get some clamps going here and get these bolted down. I've got my parts clamped down to the mill table now, so basically where the face is kind of sticking out. We're using a face mill here, so we're just going to be milling right up against these going down the table. They're kind of hanging down a little bit below the top here, the way these are on here, but they are all clamped down solid. They should not move, and we got the two straight edges here ganged together so that I can basically do two in one pass. Now, a little bit on the face mill. The face mill, I set it up earlier. I showed how to do this in a video. And when I was shooting that video, I was planning on using the inserts that were in there because I thought I had one good tooth left on all of them. Turned out some of the teeth did not have a good tooth left on them. So what I ended up doing was just ordering all new carbide for this. So I've got 10 brand new carbide inserts in here that are all ready to go again. I went back and did the same process before. Now, I was measuring with an indicator that the height of the tooth here, or how far it was sticking out. And with the old teeth, I was getting a variation in height from about 3 to 4 thousandths from the highest to the lowest. After replacing these and putting the new teeth in, they're all now within less than 1,000th of an inch, or maybe 1,000th of an inch from the highest to the lowest. So nice improvement there. And I think all we were dealing with was that we had some worn teeth on some of those, and because they were worn, they were measuring a little bit low. So that should hopefully be good. I think all these are going to be so close that it's just not going to matter. So as for the speed that we're going to be running here, I did some calculations. Now, I know that this is carbide. I'm cutting cast iron. I was able to go look it up in the books, whatever. Recommended feet per minute with a carbide cutter on just regular gray cast iron is between 220 and 300 surface feet per minute. So what that's saying is what's the speed in feet per minute of this cutter going around. So this is on a 6-inch diameter. I was able to calculate, actually I used a calculator online. I could have done it with the calculator, doing some math, but figuring out the speed around the circumference of that circle. But to get in that range, basically I needed to be running between 140 and 190 RPMs to give me that 220 to 300 feet per minute. On my milling machine, I've got 153, so we're going to be running there. And just to let you see what that looks like, that's 153 RPMs. As far as the feed rate goes, I'm just going to play around with it and listen to what's going on and come up with something that I'm comfortable with. I could have done some calculations there based on the number of teeth. There's 10 teeth in here, so every time this thing goes around, I got 10 cuts. So I should be able to run a pretty fast speed on here, but I'm just going to listen to it. I prefer to go more with what I'm seeing and what I'm hearing with my feed rate more than just looking it up in a chart. A chart will give you a good place to start, but we're just gonna go with it and see what happens. So let's get in here and start making some cuts. I'm just going to start by coming in here and just touching off on this, getting a place to start. Where I really need some rear controls. All right, we're making a light cut right there. And pull it out. And we're just going to go ahead and feed this in a little bit more. This first cut, because this bottom is irregular shaped, it's not flat, it's got some draft to it. I'm going to take I don't know if I'm going to get thicker or thinner as I go, so I'm going to start with a fairly light pass, and then after I do that one, we can make a more measured cut. So right now I'm on 2 1/8 inch feed per minute. Let's feed this on in here and start cutting. We can probably cut faster than that, but let's see what it sounds like. And I'm up to 3 1/2 inches per minute, 4 1/2. 5 3/4. I'm not in a hurry. If this was a production job, I'd probably push it farther than that, but that's cutting nice. We're just going to go with it. All right, so first pass, made excellent cut, and actually when I came back across the face, it kind of scratched it up a little bit. So this finish is where I was going at a higher speed coming back across, no big deal. I did some measurements. I want this to be about a 1/2 inch thick. We're at about 60 or 600 thousandths right now, so we're about 100 thousandths large. So I think what I'm going to do, it would probably cut 100 thousandths in one pass. In fact, I'm sure it would, but I'm just going to take it slow and easy. We're going to probably do 2 50 thousandths passes on here. So I'm going to grab my dial indicator. We'll move this thing in 50 thousandths and make another pass through here. Okay, we're 50 thousandths in farther. Let's make another pass. Oh yeah, cutting like butter. Got a little void right here in this casting that popped out. I'm hoping we can machine that out. All right, we've gone in another 50 thousandths. Let's make another pass down through here, and this should be our final cut. Well, I got those two done, but one of these has got a really bad void up in there. This is just happens when you cast sometimes. You get these little inclusions or whatever in the castings, and looks like I got caught with one of those. So what I'm going to do is I'm going to grab another casting. I got a few extras, and I'm just going to go ahead and machine another one real quick. And I'm not sure what I'm going to do with this one for right now. We may try to salvage it or do something with it later on, but it's probably just going to end up in the scrap bin. I touched off on this one, and we got a little more fun. I'm just playing around here. I'm going to take 100 thousandths pass on this one. I think it'll take it with no problem at all. So move that in. That's a full revolution on the dial indicator. We're going to let her eat and see what she likes. Let's let her eat. This casting has draft in it, so it's higher right here than it is up at the top and the bottom, so that's not really taking a full depth. We're going to take 200 total, so we'll take another 100,000th pass, and it'll be a more constant depth all the way down there after it cleans this first pass up. It's cutting through it like butter though, no problem at all. I think it would do 200 thousandths on a pass without any problem. Feed in another 100 thou and let her eat through it again. Real quick, I'm set up now. I'm going to do my 6-inch ones. And I think on these, we're just going to go for 200 thousandths, one pass, be done with it. So I got my indicator set up here. That's 100, 200. So let's see what happens. Piece of cake. That's hogging some metal off. Set up now, we're going to trim the back of this. We're going to just do a 200 thousandths pass just like we did on the other side. Just trim those right off. Get them squared up. We're done with our rough milling now. So we got the bottoms milled and we got the backs milled. And that's really what I wanted to accomplish on the milling machine here. And I got them laid out of here again. This is my pattern. This is the rough casting. This is the rough machined casting. And same thing over here. We're going to take these next to the surface grinder. That's going to be in a separate video when we do the grinding work. But what we're going to do when we grind them is we will first we're going to grind this top to get a good flat surface that's parallel to the bottom. We'll flip this over, chuck it down using some support. We'll grind the bottom, get that flat, and then we will put it in some V blocks and we will grind this surface here. And yes, ideally I think it would be best to pre-machine these, but I've done these before. It doesn't take that long to just grind it out, and quite honestly, again, like I mentioned before, work holding at that angle is kind of difficult on the milling machine. It can be done, but it's a lot easier over on the mag base on the surface grinder. So that's the game plan there to finish those out. Well, there you go, a little fun on the horizontal milling machine. I always enjoy getting a chance to use that machine for all kinds of really cool jobs in the machine shop. It's a machine that is often considered to be obsolete in today's world, and in today's world of CNC machining, you know, realistically it probably is. But for a job shop, somebody that's doing onesies and twosies, and even doing some production work, it's really a nice asset to have in a shop to do some interesting work with. As far as the straight edges go, I'm looking forward to getting these finished up. I will say, because I'm sure somebody's going to ask, I did get some extra castings made. And if somebody is interested in purchasing one of these, I don't have a whole lot of them, but and I don't know that I'm really that interested in getting into the straight edge business, but if somebody's interested in some of these other ones, give me an email, send me an email down here, and we'll see what we can work out. You know, I'm not looking to get rich off of them or anything like that. Just wanted to make sure I had enough to do what I was going to do, and maybe pass a few around that you other folks can put to use as well. So with that, that'll be a wrap, guys, and we'll be back in another episode to finish grinding these things out and then get them scraped out as well and have some nice new tools for the shop. Thanks for watching.